Hello there, and welcome to the Sleepy Astronomer channel. Tonight, we're drifting to Mars, the red planet, our mysterious neighbor in the solar system. I'm so glad you found your way here, to this quiet space, where we can explore together, gently, peacefully, without any rush. Perhaps your day has been long, or your mind is still spinning with thoughts, or maybe you simply love falling asleep to the gentle rhythm of space exploration. Whatever brought you here tonight, this time is yours. There's nothing you need to do, nowhere you need to be. Just let your muscles soften, your breathing slow, and your thoughts drift like dust across the Martian plains. Tonight, we're going to float gently across Mars. From its towering volcanoes to its ancient river valleys, from polar ice caps to canyon systems that dwarf anything on Earth. We'll explore a world that once had water, that may still harbor life, and that humans may one day call home. Some of what you hear may surprise you, or simply give your mind something peaceful to hold as sleep finds you. And if you drift away before our journey ends, that's perfectly fine. Mars will still be there, turning slowly in the darkness, waiting. Now, let's begin our journey to the red planet. The red planet. Mars appears red in our night sky. This distinctive color has fascinated humans for thousands of years. Ancient cultures named it after their gods of war because of its blood-red appearance. The Romans called it Mars, the Greeks called it Ars, the Egyptians called it Hadessa, the red one. But the red color isn't mysterious. It comes from iron oxide, rust, covering the surface. Mars is essentially a rusty planet, its rocks and soil rich in iron that has oxidized over billions of years. From Earth, Mars shines brightly in the night sky, sometimes rivaling the brightest stars. Its red glow is unmistakable, a beacon, calling to us from across the void. The fourth planet. Mars is the fourth planet from the Sun. It orbits at an average distance of about 228 million kilometers. That's about 1.5 times farther from the Sun than Earth. Because of this distance, sunlight on Mars is only about 44% as bright as on Earth. If you stood on Mars, the Sun would appear about 2/3 the size it appears from Earth. Smaller, but still bright enough to light the rusty landscape. Mars takes about 687 Earth days to complete one orbit around the Sun. That's nearly 2 Earth years for one Martian year. But a day on Mars, called a sol, is remarkably similar to an Earth day. One sol lasts 24 hours and 37 minutes. This similarity makes Mars feel almost familiar, a world where our clocks would barely need adjusting. A small world. Mars is smaller than Earth. Its diameter is about 6,779 kilometers, roughly half the diameter of Earth. If Earth were the size of a basketball, Mars would be the size of a softball. This smaller size means Mars has less gravity, about 38% of Earth's. If you weigh 100 pounds on Earth, you'd weigh only 38 pounds on Mars. You could jump nearly 3 times higher, and objects would fall more slowly. Walking on Mars would feel bouncy, almost dreamlike. Mars is the second smallest planet in the solar system. Only Mercury is smaller. But despite its size, Mars holds enormous secrets and captures our imagination like no other world. The thin atmosphere. Mars has an atmosphere, but it's incredibly thin. The atmospheric pressure at the surface is less than 1% of Earth's. It's so thin, it's almost like a vacuum. The atmosphere is made mostly of carbon dioxide, about 95%, with traces of nitrogen, argon, and oxygen. There's not enough oxygen to breathe, and not enough pressure to survive without a spacesuit. If you stepped onto Mars without protection, the low pressure would cause the liquids in your body to boil. It would be unpleasant. The thin atmosphere also means Mars has almost no protection from radiation. Cosmic rays and solar radiation reach the surface, making it a harsh environment for life. But the atmosphere is thick enough to create weather, winds, clouds, and dust storms. It's enough to make Mars feel alive in its own way. Martian seasons. Mars has seasons, just like Earth. This is because Mars is tilted on its axis, about 25 degrees, very similar to Earth's 23.5-degree tilt. As Mars orbits the Sun, different parts of the planet receive more or less sunlight, creating seasons. Spring, summer, fall, and winter all exist on Mars. But Martian seasons are nearly twice as long as Earth's, because the Martian year is almost twice as long. Spring and summer in the northern hemisphere last longer than fall and winter, because Mars's orbit is more elliptical than Earth's. When Mars is farther from the Sun, the seasons are longer. During winter, carbon dioxide freezes out of the atmosphere, forming a layer of dry ice at the poles. During summer, this ice sublimates, turning directly from solid to gas, releasing it back into the atmosphere. Mars breathes, slowly, with the rhythm of its seasons. The polar ice caps. Mars has polar ice caps, visible even through small telescopes from Earth. These ice caps grow and shrink with the seasons. They're made of two types of ice, water ice and carbon dioxide ice, also known as dry ice. In winter, the ice caps can extend halfway to the equator, covered in a layer of frozen carbon dioxide. In summer, the dry ice sublimates, leaving behind permanent caps of water ice. The northern ice cap is larger and contains most of Mars's water ice. If it melted, it would cover the entire planet in a layer of water about 10 meters deep. The southern ice cap is smaller and sits on higher terrain. Both ice caps are layered, like tree rings, recording millions of years of climate history. Scientists study these layers to understand how Mars's climate has changed over time. The ice caps are beautiful, white against the red planet, like frozen crowns. Olympus Mons, the tallest volcano. Mars is home to the tallest volcano in the solar system, Olympus Mons. It rises nearly 22 kilometers above the surrounding plains, almost 3 times the height of Mount Everest. It's so large, it would cover the entire state of Arizona. Olympus Mons is a shield volcano, built up over millions of years by lava flows. Its slopes are gentle, only about 5 degrees, so climbing it would be like walking up a gradual hill. But it would take days, maybe weeks, to reach the summit. At the top is a caldera, a collapsed volcanic crater, about 80 kilometers wide. Olympus Mons is so tall that if you stood at its base, you couldn't see the summit, it would curve beyond the horizon. And if you stood at the summit, you'd be above much of Mars's thin atmosphere, looking out at the curve of the planet below. Olympus Mons is probably extinct. It hasn't erupted in millions of years. But it stands as a monument to the volcanic power that once shaped Mars. The Tharsis region. Olympus Mons is not alone. It sits on a vast volcanic plateau called the Tharsis region. This region contains several other massive volcanoes, including Olympus Mons, Pavonis Mons, and Asha Mons. These three volcanoes form a line, like sentinels, standing tall above the Martian plains. The Tharsis region is a massive bulge on Mars's surface, about 4,000 kilometers across. It rises several kilometers above the average surface level. The weight of all this volcanic rock has actually warped Mars's crust, creating fractures and canyons elsewhere on the planet. Tharsis is one of the most prominent features on Mars, visible even from orbit. It's a reminder that Mars was once geologically active, with volcanoes, lava flows, and tectonic forces reshaping the surface. Valles Marineris, the Grand Canyon of Mars. On the opposite side of Mars from Tharsis lies Valles Marineris, the grandest canyon system in the solar system. It stretches over 4,000 kilometers, about a quarter of the way around Mars. It's 10 times longer than the Grand Canyon on Earth, and it's much deeper, in some places up to 7 kilometers deep. If Valles Marineris were on Earth, it would stretch from New York to Los Angeles. The canyon system was formed billions of years ago, likely as a result of tectonic stress caused by the formation of the Tharsis bulge. As Tharsis rose, the crust on the opposite side cracked and collapsed, creating these enormous valleys. Some parts of Valles Marineris may have been widened by water erosion, or landslides, or ancient floods. Standing on the rim of Valles Marineris, you would see cliffs stretching to the horizon, layers of rock exposed, telling the story of Mars's ancient past. It is a scar, a wound in the planet's surface, beautiful and humbling. Ancient water on Mars. Mars was not always dry. Billions of years ago, Mars had liquid water on its surface. Rivers carved valleys into the highlands. Lakes filled ancient craters. And there may have been oceans, vast and deep, covering much of the northern hemisphere. We know this because of the evidence left behind. Dried river channels, delta formations, sedimentary rock layers, minerals that form only in the presence of water. Spacecraft orbiting Mars have mapped these features, revealing a planet that once looked very different. Warmer, wetter, and possibly habitable. But something changed. Mars lost its magnetic field, and without that protection, the solar wind stripped away much of the atmosphere. The water evaporated into space, or froze beneath the surface. Today, Mars is cold and dry, but the ghosts of ancient rivers still whisper across the landscape. Water ice on Mars today. Though liquid water no longer flows on the surface, Mars still has water, frozen, hidden beneath the surface, and locked in the polar ice caps. In 2018, scientists discovered a large lake of liquid water beneath the southern ice cap, kept liquid by pressure and salt, even in the freezing conditions. There are likely more such lakes, buried beneath the ice. In certain regions, ice is just centimeters below the surface, covered by a thin layer of dust. Spacecraft have detected water ice in craters near the poles and in mid-latitude regions. If humans ever visit Mars, this ice will be crucial. It can be melted for drinking water, split into hydrogen and oxygen for fuel and breathable air. Mars's water is not gone, it's just sleeping, waiting. The two moons of Mars. Mars has two small moons, Phobos and Deimos, named after the companions of Ars, the Greek god of war, fear and panic. Both moons are tiny, irregularly shaped, and heavily cratered. Phobos is the larger of the two, about 22 kilometers across at its widest point. It orbits very close to Mars, completing one orbit every 7 hours and 39 minutes. Because it orbits so fast, Phobos rises in the west and sets in the east, opposite to how our moon moves. It's also slowly spiraling inward, pulled by Mars's gravity. In about 50 million years, Phobos will either crash into Mars or break apart, forming a ring around the planet. Deimos is smaller, about 12 kilometers across, and orbits farther out. It takes about 30 hours to complete one orbit. From the surface of Mars, Deimos would look like a bright star, not much larger than Venus appears from Earth. Both moons are thought to be captured asteroids, pulled in by Mars's gravity long ago. They're dark, ancient, and mysterious. The Martian sky. The sky on Mars is not blue, like Earth's. During the day, it appears butterscotch, a pale orange or tan color. This is because of dust particles suspended in the thin atmosphere. Sunlight scatters off the dust, giving the sky its warm hue. But at sunrise and sunset, the Martian sky turns blue around the sun. This is the opposite of Earth, where sunsets are red and the daytime sky is blue. On Mars, the dusty atmosphere scatters red light during the day, but when the sun is low, blue light scatters more directly toward you. At night, the stars would be incredibly bright, undiminished by thick atmosphere or light pollution. You could see stars down to the horizon, and the Milky Way would stretch across the sky, vivid and clear. Occasionally, you might see Earth, a bright blue star, rising in the Martian night. The Martian sky is alien, but beautiful in its own strange way. Dust storms on Mars. Mars is famous for its dust storms. Some are small, localized whirlwinds called dust devils, spinning across the plains. Others are regional, covering areas the size of continents. And sometimes, every few years, a dust storm grows so large it engulfs the entire planet. These global dust storms can last for weeks or even months. The dust blocks sunlight, cooling the surface and making it nearly impossible for solar-powered spacecraft to operate. In 2018, a global dust storm ended the mission of NASA's Opportunity rover, which had been exploring Mars for nearly 15 years. Dust storms on Mars are driven by temperature differences, and by the thin atmosphere. The winds can reach speeds of 100 kilometers per hour, though because the atmosphere is so thin, they wouldn't feel as strong as winds on Earth. You could stand in a Martian dust storm, and the wind wouldn't knock you over. But the dust would be everywhere, fine as talc, clinging to everything, blotting out the sun. Dust devils. On clear days, Mars's surface is dotted with dust devils. Whirlwinds of dust, spinning slowly across the plains. They form when sunlight heats the ground, creating rising columns of warm air. As the air rises, it begins to spin, picking up dust and carrying it high into the atmosphere. Dust devils on Mars can be enormous, much larger than those on Earth. Some reach heights of 10 kilometers or more, towering columns visible from orbit. NASA's rovers have observed hundreds of dust devils. Some have even passed directly over the rovers, briefly cleaning dust off their solar panels. Watching a Martian dust devil would be mesmerizing, a slow, graceful spiral, moving across the red landscape, silent in the thin air. The Martian year and calendar. A year on Mars lasts 687 Earth days, nearly twice as long as an Earth year. But because a Martian day, a sol, is only slightly longer than an Earth day, a Martian year contains about 668 sols. Scientists have developed a calendar for Mars, dividing the year into 24 months, each with a name based on Latin or Greek. Some proposed calendars give Martian months about 28 sols each, similar to lunar months on Earth. Keeping track of time on Mars is important for mission planning, especially as rovers and landers operate for months or years. The seasons, the position of the sun, the length of daylight, all follow predictable patterns. If humans ever settle on Mars, they'll need calendars, clocks, and ways of marking time. It's strange to think that one day, children might celebrate birthdays on Mars, counting not years, but Martian years, twice as rare, twice as precious. Martian sunrises and sunsets. On Mars, the sun rises and sets, just as it does on Earth. But because a sol is 37 minutes longer than an Earth day, the timing slowly drifts. If you visited Mars, your sleep schedule would gradually shift, unless you adjusted your clocks. Sunrises and sunsets on Mars are beautiful. The sun appears smaller, about 2/3 the size it appears from Earth. As it rises, the sky around it glows blue, a small patch of color in the butterscotch sky. As it sets, the blue deepens, fading slowly as the sun dips below the horizon. Then, twilight, long and gradual, the sky darkening through shades of orange and pink. At night, the temperature plummets, dropping by 100 degrees Celsius or more. Mars has no thick atmosphere to trap heat, so the warmth of the day escapes quickly into space. Standing on Mars, watching the sun set, you would feel the cold creeping in, a reminder of how hostile this world can be. The search for life on Mars. One of the biggest questions about Mars is, has it ever harbored life? The answer is still unknown, but there are reasons to be hopeful. Mars once had liquid water, a key ingredient for life as we know it. It had a thicker atmosphere, and possibly a warmer climate. Organic molecules, the building blocks of life, have been detected in Martian soil. And there are places on Mars, even today, where conditions might support microbial life. Subsurface lakes, protected from radiation. Seasonal briny water flows, appearing during warm months. Deep underground, where geothermal heat might keep water liquid. NASA and other space agencies are actively searching for signs of past or present life. Rovers drill into rocks, analyze soil samples, and search for biosignatures. Future missions will bring samples back to Earth for detailed analysis. We may be on the verge of answering one of humanity's oldest questions. Are we alone? Viking landers, the first search. In 1976, NASA's Viking 1 and Viking 2 landers touched down on Mars. They were the first spacecraft to successfully land on the Red Planet and operate for an extended period. Each lander carried instruments designed to search for life. They scooped up soil, mixed it with nutrients, and looked for signs of metabolism. The results were confusing. Some tests seemed to show signs of life, others did not. To this day, scientists debate what the Viking landers found. Most believe the reactions were chemical, not biological. But a few scientists still wonder, did Viking detect life, and we just didn't recognize it? The Viking landers also sent back the first color images of Mars's surface. Rusty red rocks, a butterscotch sky, and distant horizons. They showed us Mars, not as a point of light in the sky, but as a real place. The Curiosity rover. In 2012, NASA's Curiosity rover landed in Gale Crater. A car-sized robot, equipped with cameras, drills, and a laser. Curiosity's mission is to explore Mars, analyze rocks, and search for signs that Mars was once habitable. Over the years, Curiosity has made remarkable discoveries. It found evidence of ancient lakes and streams, where water once flowed for thousands or even millions of years. It detected organic molecules, complex carbon compounds, preserved in ancient rocks. It measured radiation levels, helping scientists understand the challenges humans would face on Mars. And it climbed Mount Sharp, a mountain inside Gale Crater, studying layers of rock that record Mars's climate history. Curiosity is still active, still exploring, still sending back data. It drives slowly across the Martian surface, stopping to drill, to analyze, to photograph. It's our eyes and hands on Mars, a robotic explorer, doing what we cannot yet do ourselves. The Perseverance rover and Ingenuity helicopter. In 2021, NASA's Perseverance rover landed in Jezero Crater. This crater was once home to an ancient lake and a river delta. If life ever existed on Mars, Jezero Crater is one of the best places to look. Perseverance is equipped with advanced instruments, including a drill that can collect rock samples and seal them in tubes. These samples will be left on the surface for a future mission to collect and bring back to Earth. But Perseverance didn't come alone. Attached to its belly was Ingenuity, a small robotic helicopter. Ingenuity made history, becoming the first aircraft to fly on another planet. It proved that flight is possible in Mars's thin atmosphere, opening up new ways to explore. Ingenuity completed dozens of flights, scouting ahead for Perseverance, testing new technologies. Together, Perseverance and Ingenuity are exploring Mars in ways we never could before. Evidence of ancient rivers. Mars's surface is covered in dried river channels, winding valleys, carved by flowing water billions of years ago. Some of these channels are small, like creeks. Others are massive, like the Mississippi River, stretching for hundreds of kilometers. The channels often end in fan-shaped deposits, deltas, where rivers emptied into lakes or seas. These features are unmistakable. They could only have been formed by liquid water. Scientists have mapped thousands of these ancient river systems, reconstructing the hydrology of ancient Mars. There were highlands where rain or snowmelt collected, rivers that flowed downhill, carving valleys, lakes that filled and dried over and over. Mars was once a world of water, dynamic and changing. Looking at these dried rivers, it's hard not to imagine what Mars might have looked like. Blue skies, flowing water, perhaps even life. Recurring slope lineae. One of the most intriguing discoveries on Mars is recurring slope lineae, or RSL. These are dark streaks that appear on steep slopes during warm months and fade during cold months. They were first discovered in 2011 by NASA's Mars Reconnaissance Orbiter. At first, scientists thought they might be caused by liquid water, salty brines that flow downhill during summer. If true, it would mean liquid water still exists on Mars's surface, at least seasonally. But further study has cast doubt on this idea. The streaks may be caused by dry sand flows, triggered by frost or other processes. The debate continues. RSL remain one of Mars's mysteries, hints that something strange is happening. Something we don't fully understand yet. Methane in the atmosphere. Mars's atmosphere contains traces of methane. This is surprising, because methane is a fragile molecule, quickly destroyed by sunlight. For methane to exist in the atmosphere, something must be producing it, recently. On Earth, most methane is produced by biological processes, bacteria, plants, animals. But methane can also be produced by geological processes, like volcanic activity or chemical reactions in rocks. On Mars, the source of methane is unknown. The Curiosity rover has detected spikes of methane, sudden increases in concentration, that fade quickly. Orbital spacecraft have also detected methane plumes. Is the methane biological or geological? We don't know yet. But the presence of methane is exciting because it suggests Mars is not completely dead. Something is happening beneath the surface, releasing gas into the atmosphere. Gale crater. Gale crater is where the Curiosity rover has been exploring since 2012. It's a large impact crater, about 154 kilometers across, formed billions of years ago when an asteroid struck Mars. Over time, the crater filled with sediment, layers of rock deposited by wind and water. Then, erosion carved away much of this material, leaving behind a central mountain. Mount Sharp. Mount Sharp rises about 5 kilometers above the crater floor. Its layers are like pages in a book, each one recording a different period in Mars's history. By driving up Mount Sharp and studying each layer, curiosity is reading Mars's ancient past. Lower layers show evidence of lakes and rivers. Higher layers show a shift to drier conditions. Gale Crater is a time capsule, preserving billions of years of Martian climate history. Jezero Crater. Jezero Crater is where the Perseverance rover landed in 2021. It's smaller than Gale Crater, about 45 kilometers across. But it has something special. A river delta. Billions of years ago, a river flowed into Jezero Crater, depositing sediment in layers at the edge of an ancient lake. This delta is clearly visible from orbit, a fan-shaped deposit of rock and soil. Deltas are excellent places to search for signs of ancient life. On Earth, deltas preserve fossils, organic material, and biosignatures. If life ever existed on Mars, Jezero's delta might hold the evidence. Perseverance is slowly exploring the delta, drilling samples, and searching for clues. Olympus Mons's caldera. At the summit of Olympus Mons, the tallest volcano in the solar system, lies a massive caldera. A caldera is a collapsed volcanic crater formed when a magma chamber empties and the ground above it sinks. Olympus Mons's caldera is about 80 kilometers wide and contains several overlapping craters. This suggests the volcano erupted multiple times, with collapses happening at different stages. Standing on the rim of this caldera, you would see cliffs dropping away into darkness, the walls steep and imposing. The caldera floor is far below, scarred with ancient lava flows. Olympus Mons has been quiet for millions of years, possibly extinct. But its caldera remains, a monument to the volcanic forces that built this giant. The dichotomy of Mars. Mars has two very different hemispheres. The southern hemisphere is heavily cratered, ancient, and high in elevation. The northern hemisphere is smooth, younger, and low in elevation. This difference is called the Martian dichotomy. The boundary between the two hemispheres is sharp, a slope that drops several kilometers. Scientists aren't sure what caused this. One theory suggests a massive impact early in Mars's history that blasted away the crust in the north. Another theory suggests internal processes, like mantle convection, created the difference. Whatever the cause, the dichotomy is one of Mars's most striking features. It divides the planet, giving it two faces, two stories. Ancient oceans. Some scientists believe the northern lowlands once held an ocean, a vast body of water covering much of the northern hemisphere. Evidence includes ancient shorelines, sedimentary deposits, and minerals that form underwater. If this ocean existed, it would have been huge, comparable to Earth's Mediterranean Sea. But it wouldn't have lasted forever. As Mars's climate changed and the atmosphere thinned, the ocean would have evaporated or frozen. Today, the northern lowlands are dry, covered in dust and volcanic plains. But beneath the surface, ice may still remain, a frozen remnant of ancient seas. Crater counting. One way scientists determine the age of a surface on Mars is by counting craters. Older surfaces have more craters because they've been exposed to impacts for longer. Younger surfaces have fewer craters because they've been resurfaced more recently by lava flows or erosion or other processes. By counting craters in images taken from orbit, scientists can estimate when different regions formed. The southern highlands are ancient, over 4 billion years old. The volcanic plains of Tharsis are younger, perhaps 2 to 3 billion years old. Some lava flows are only a few 100 million years old. Crater counting is like reading a clock, written in stone, across the Martian surface. Tektites and Martian meteorites. We have pieces of Mars, here on Earth. They're called Martian meteorites. These rocks were blasted off Mars by asteroid impacts, launched into space, and eventually fell to Earth. Over 200 Martian meteorites have been found, mostly in Antarctica and desert regions. Studying these meteorites tells us about Mars's geology, composition, and history. One famous meteorite, ALH 84001, caused excitement in the 1990s when scientists claimed it contained fossils of Martian bacteria. Further study cast doubt on this claim, but the debate continues. Martian meteorites are precious, fragments of another world, delivered to us by chance. Mars's lost magnetic field. Mars once had a global magnetic field, like Earth's. This field was generated by a molten iron core, dynamo effect, billions of years ago. But about 4 billion years ago, the magnetic field disappeared. The core cooled and solidified, and the dynamo shut down. Without a magnetic field, Mars was exposed to the solar wind. Charged particles from the Sun stripped away the atmosphere, slowly, over millions of years. The atmosphere thinned, the pressure dropped, and liquid water could no longer exist on the surface. The loss of the magnetic field may have been the turning point, the moment Mars became the cold, dry planet we see today. Remnants of the ancient magnetic field remain, frozen in rocks, like fossils of a lost shield. The Utopia Planitia region. Utopia Planitia is a vast plain in Mars's northern hemisphere. It's one of the largest impact basins in the solar system, over 3,000 kilometers across. In 1976, NASA's Viking 2 lander touched down here. It sent back images of a flat, rocky landscape, stretching to the horizon. More recently, China's Zhurong rover landed in Utopia Planitia in 2021. The region is of interest because radar observations suggest there's a massive deposit of ice beneath the surface. This ice, if confirmed, could be a valuable resource for future human missions. Utopia Planitia is quiet, flat, and seemingly empty. But beneath the dust, it may hold treasures. Hellas Basin. Hellas Basin is the largest visible impact crater on Mars. It's over 2,300 kilometers across and 7 kilometers deep. The impact that created it must have been catastrophic, reshaping the entire planet. Hellas Basin is so deep that the atmospheric pressure at the bottom is nearly twice that of the surrounding highlands. This makes it one of the few places on Mars where liquid water, under the right conditions, might briefly exist. The basin floor is relatively smooth, filled with dust and ice. In winter, carbon dioxide frost covers the basin, turning it white. Hellas Basin is a scar, a reminder of the violent history of the solar system, when massive asteroids roamed and impacts were common. Noctis Labyrinthus. At the western end of Valles Marineris lies Noctis Labyrinthus, the labyrinth of night. It's a maze of deep valleys, narrow canyons, and blocky plateaus. The valleys intersect at chaotic angles, forming a tangled web. Noctis Labyrinthus was formed by tectonic stress and collapse, as the Tharsis region rose and the crust fractured. It's a region of geological chaos, beautiful and bewildering. From orbit, it looks like a shattered window, cracks spreading in all directions. If you could fly through Noctis Labyrinthus, you would see towering cliffs, shadowed valleys, and endless twists and turns. It's one of Mars's most dramatic landscapes. The Canale controversy. In the late 1800s, Italian astronomer Giovanni Schiaparelli observed Mars through a telescope. He saw what appeared to be long, straight lines crisscrossing the surface. He called them canali, meaning channels. But when translated to English, the word became canals, implying they were artificial. This sparked a frenzy of speculation. American astronomer Percival Lowell championed the idea that Mars was inhabited by an advanced civilization. He believed the canals were irrigation systems, built to transport water from the poles to the equator. He wrote books, gave lectures, and built an observatory to study Mars. But as telescopes improved, the canals disappeared. They were optical illusions, tricks of the eye, caused by the brain connecting random features. There were no canals, no Martians, no civilization. But the idea captured the public imagination and inspired countless stories, books, and films. Mars became the home of science fiction, a place of mystery and wonder. The face on Mars. In 1976, NASA's Viking 1 orbiter photographed a region called Cydonia. One image showed a mesa, a flat-topped hill, that resembled a human face. The face on Mars became famous, fueling speculation about ancient Martian civilizations. Some people believed it was a monument, built by intelligent beings. But high-resolution images, taken decades later, revealed the truth. The face was just a natural rock formation. Shadows and low resolution had created the illusion. When lit from different angles, it looked nothing like a face. The face on Mars is a reminder that our brains are wired to see patterns, even where none exist. It's called pareidolia, the tendency to see faces in random shapes. Mars is full of natural wonders, but they're not built by Martians. Mars's eccentric orbit. Mars's orbit around the Sun is more elliptical than Earth's. At its closest, Mars is about 207 million kilometers from the Sun. At its farthest, it's about 249 million kilometers away. This means the amount of sunlight Mars receives varies significantly throughout its year. When Mars is closest to the Sun, the southern hemisphere experiences summer and temperatures rise. This can trigger dust storms, as the warmed surface creates strong winds. When Mars is farthest from the Sun, temperatures drop, and ice accumulates at the poles. This orbital eccentricity affects Mars's climate, creating more extreme seasonal changes than we experience on Earth. Phobos's grooves. Phobos, Mars's larger moon, is covered in strange grooves. These grooves are long, parallel lines stretching across the surface. For years, scientists debated what caused them. Some thought they were fractures caused by tidal stress as Mars's gravity pulls on Phobos. Others believed they were chains of craters formed by debris from impacts. Recent studies suggest the grooves are indeed stress fractures. Phobos is slowly spiraling toward Mars, and the gravitational forces are tearing it apart. The grooves are early signs of Phobos's eventual destruction. They run across the surface like scars, marking a moon in its final millennia. The Stickney crater. The largest crater on Phobos is called Stickney. It's about 9 kilometers across, nearly half the size of Phobos itself. The impact that created Stickney must have nearly shattered the moon. If the asteroid had been slightly larger, Phobos would have been destroyed. Instead, Phobos survived, but the impact left deep scars. Fractures radiate from Stickney, spreading across the surface. The crater is named after Angeline Stickney, the wife of Asaph Hall, the astronomer who discovered Phobos and Deimos in 1877. Standing on the rim of Stickney, you would see walls dropping away into shadow, and Mars hanging enormous in the sky above. Mars's axial precession. Mars's axis wobbles, slowly, over long periods of time. This wobble is called axial precession, or the precession of the equinoxes. Earth experiences this too, though on a timescale of about 26,000 years. On Mars, the wobble is more extreme, and happens over about 170,000 years. But Mars also experiences changes in its axial tilt, called obliquity variations. Over tens of thousands of years, Mars's tilt can vary from about 15 degrees to 35 degrees. When the tilt is greater, the poles receive more sunlight, and more ice melts into the atmosphere. This can trigger dramatic climate changes, including global dust storms. Some scientists believe these orbital cycles have caused Mars to alternate between ice ages and warmer periods. Understanding these cycles helps us understand Mars's climate history. Layers in the polar ice. The polar ice caps of Mars are layered, like a stack of thin pancakes. Each layer is only a few meters thick, and represents a different period of time. The layers are visible in high-resolution images, alternating between bright and dark. Bright layers are made of water ice, mixed with dust. Dark layers contain more dust and less ice. These layers record changes in Mars's climate over millions of years. By studying them, scientists can reconstruct how much ice accumulated, how much dust fell, and how the atmosphere changed. It's like reading tree rings, but on a planetary scale. The polar layers are a climate archive, a frozen library, waiting to be read. The lost atmosphere. Mars's atmosphere was once much thicker, perhaps thick enough to support liquid water on the surface for long periods. But over billions of years, the atmosphere was stripped away. Without a magnetic field to protect it, the solar wind eroded the upper atmosphere. Atoms and molecules were knocked away, escaping into space. NASA's MAVEN spacecraft, which has been orbiting Mars since 2014, has studied this process. It measures how much atmosphere Mars loses each day. The rate is small, but over billions of years, it adds up. Mars lost most of its atmosphere long ago, but the process continues, even now. Every day, Mars becomes a little thinner, a little more exposed. Potential for human colonization. Mars is the most likely candidate for human colonization in the solar system. It's relatively close, with travel times of about 6 to 9 months. It has a day length similar to Earth's, making it easier for humans to adapt. It has water ice, which can be used for drinking, agriculture, and making fuel. It has resources, like iron, silicon, and other minerals. And its gravity, though weaker than Earth's, is strong enough that humans could adapt without severe health consequences. But Mars is also hostile. The atmosphere is too thin to breathe and offers little protection from radiation. Temperatures are brutally cold, averaging around -60 degrees Celsius. Dust storms can last for months. Building a permanent settlement on Mars would require advanced technology, reliable life support systems, and enormous resources. But it's not impossible. Many space agencies and private companies are planning missions to Mars. One day, humans may walk on the red planet and call it home. The Mars Sample Return Mission. One of the most ambitious missions planned for Mars is the Mars Sample Return Mission. This is a joint effort between NASA and the European Space Agency. The Perseverance rover is currently collecting rock and soil samples, sealing them in tubes. These tubes will be left on the surface at designated sites. In the future, a lander will touch down on Mars, deploy a small rover, and collect the tubes. The samples will be loaded onto a rocket, launched into orbit around Mars, and transferred to a spacecraft. That spacecraft will then return to Earth, where the samples will be studied in laboratories. This mission will take years, but it will be worth it. Martian samples, analyzed with equipment far more advanced than what we can send to Mars, could answer fundamental questions. Did life ever exist on Mars? What is Mars made of? How did its climate change? The Mars Sample Return Mission could revolutionize our understanding of the red planet. Terraforming Mars. Some scientists and visionaries have proposed terraforming Mars, transforming it into a more Earth-like planet with a thicker atmosphere, warmer temperatures, and possibly even liquid water on the surface. The idea is to release greenhouse gases, like carbon dioxide, to warm the planet. This could be done by melting the polar ice caps, or by importing gases from elsewhere in the solar system. As the planet warms, more ice would melt, releasing more carbon dioxide and water vapor, creating a feedback loop. Eventually, the atmosphere could become thick enough to support liquid water. plants could be introduced to produce oxygen through photosynthesis. Over centuries or millennia, Mars might become habitable, but terraforming Mars would be an enormous undertaking, requiring technologies we don't yet have. And it raises ethical questions. Do we have the right to change another planet? What if life already exists on Mars, hidden beneath the surface? For now, terraforming remains a dream, a possibility for the distant future. Radiation on Mars. One of the biggest challenges for human missions to Mars is radiation. On Earth, we're protected by a thick atmosphere and a magnetic field. On Mars, there is no magnetic field, and the atmosphere is thin. Cosmic rays, high-energy particles from space, reach the surface unimpeded. Solar flares, bursts of radiation from the sun, are also a threat. Over time, exposure to this radiation increases the risk of cancer and other health problems. Astronauts on Mars would need protection. This could include habitats built underground or covered with thick layers of Martian soil. Spacesuits would need additional shielding, and mission durations would need to be limited to reduce cumulative exposure. Radiation is a serious obstacle, but not insurmountable. With proper precautions, humans can survive on Mars. Perchlorate in Martian soil. The soil on Mars contains perchlorates. These are chemical compounds made of chlorine and oxygen. They're toxic to humans and can interfere with thyroid function. Perchlorates were detected by NASA's Phoenix lander in 2008 and confirmed by later missions. Their presence complicates plans for human settlement. Martian soil cannot be used directly for agriculture unless the perchlorates are removed. Water extracted from the soil would need to be purified. But perchlorates also have a useful property. They lower the freezing point of water. This means that even at very cold temperatures, water mixed with perchlorates can remain liquid. This could explain some of the seasonal features observed on Mars, like recurring slope lineae. Perchlorates are a challenge, but also a clue to understanding Mars's chemistry. The color of Martian soil. Martian soil is red, rusty, and dusty. The red color comes from iron oxide, rust, coating the surface. But beneath the red dust, the soil is more varied. Some regions have dark volcanic rock. Others have lighter colored sediments deposited by ancient water. The Curiosity rover drilled into rocks, revealing gray interiors beneath the red surface. The red dust is fine, like talc, and it gets everywhere. It coats rocks, rovers, and would coat spacesuits. It's also slightly magnetic because of the iron content. The dust is a constant presence on Mars, blown by the wind, settling in layers, covering ancient landscapes. Blue sunsets. On Mars, sunsets are blue. This is the opposite of Earth, where sunsets are red or orange. The difference comes from the dust in Mars's atmosphere. During the day, sunlight scatters off dust particles, giving the sky its butterscotch color. But at sunset, when the sun is low on the horizon, blue light scatters more directly toward you. The result is a small patch of blue surrounding the setting sun, against a darker orange sky. NASA's rovers have captured images of these blue sunsets. They're hauntingly beautiful, serene, a reminder that Mars is a world of wonders. Watching a Martian sunset, you would see the sun shrink, turn blue, and slowly sink below the horizon. The sky would darken, stars would appear, and the temperature would plummet. It would be alien, but peaceful. Mars's moment of inertia. Scientists can learn about Mars's interior by studying its moment of inertia. This is a measure of how mass is distributed inside the planet. By tracking how Mars wobbles as it orbits the Sun, scientists can infer the structure of its core, mantle, and crust. Mars has a core made of iron, nickel, and sulfur. The core is partially liquid, though not as active as Earth's core. Surrounding the core is a rocky mantle, and above that, a thin crust. The crust is thicker in the southern highlands and thinner in the northern lowlands. Understanding Mars's internal structure helps scientists understand how it formed and how it evolved. It's like taking an X-ray of the planet, seeing what lies beneath the surface. Mars quakes. Mars experiences quakes, called Mars quakes. These are seismic events caused by the cracking of the crust or by cooling and contraction of the interior. NASA's InSight lander, which operated from 2018 to 2022, detected hundreds of Mars quakes. Most were small, barely perceptible, but some were larger, magnitude 4 or 5, strong enough to shake the lander. By studying Mars quakes, scientists learned about Mars's interior structure. Seismic waves travel through the planet, and their speed and direction reveal the composition of the mantle and core. Mars quakes are much less frequent than earthquakes because Mars is less geologically active. But they prove that Mars is not completely dead. It still shifts, still moves, still breathes in its own slow way. The InSight lander. NASA's InSight lander touched down on Mars in 2018. Its mission was to study the planet's interior using a seismometer, a heat probe, and other instruments. InSight stood in one place, on a flat plain called Elysium Planitia. It listened, measured, and sent data back to Earth. Over 4 years, InSight detected hundreds of Mars quakes, measured heat flow, and tracked Mars's wobble. It also captured sounds, the wind blowing across the surface, the rumble of distant quakes. InSight's mission ended in 2022, when dust covered its solar panels, and it ran out of power. But its legacy remains, a wealth of data, helping us understand what lies beneath Mars's surface. Ice clouds on Mars. Mars has clouds, thin and wispy, drifting high in the atmosphere. Most are made of water ice, similar to cirrus clouds on Earth. They form in the early morning, when temperatures are coldest. As the sun rises, the clouds evaporate, disappearing into the thin air. There are also clouds made of carbon dioxide ice, dry ice. These form at very high altitudes or near the poles during winter. Clouds on Mars are delicate, translucent, and beautiful. Rovers and orbiters have photographed them, capturing their subtle shapes. Watching clouds drift across the Martian sky, you would see them move slowly, silently, in the thin atmosphere. They're a reminder that Mars, though cold and dry, still has weather, still has an atmosphere, however faint. The Opportunity rover. NASA's Opportunity rover landed on Mars in 2004. It was designed to last 90 days. But it kept going for nearly 15 years. Opportunity explored Meridiani Planum, a flat plain near the Martian equator. It discovered evidence of ancient water, hematite spherules nicknamed blueberries, formed in water-rich environments. It explored craters, climbed hills, and traveled over 45 kilometers, farther than any other Mars rover. Opportunity's mission ended in 2018 during a global dust storm. Dust covered its solar panels, blocking sunlight, and the rover lost power. Engineers sent commands, hoping it would wake up, but it never did. Opportunity's final resting place is in Perseverance Valley, a fitting name. The rover persevered far beyond expectations and gave us a decade and a half of discoveries. The Spirit rover, Opportunity's twin. Spirit landed on the opposite side of Mars, in Gusev crater. Spirit also far exceeded its planned 90-day mission, operating for over 6 years. It explored the Columbia Hills, discovered signs of ancient hot springs, and endured harsh Martian winters. In 2009, Spirit became stuck in soft sand. Despite months of effort, engineers couldn't free it. Spirit continued to operate as a stationary science platform until 2010, when communication was lost. Spirit and Opportunity were pioneers, proving that rovers could survive and thrive on Mars. They paved the way for Curiosity, Perseverance, and future missions. The search for methane sources. The mystery of Mars's methane continues to intrigue scientists. Several missions have detected methane, but its source remains unknown. Some scientists are searching for active vents, places where methane is released from underground. Others are looking for seasonal patterns to see if methane correlates with temperature or other factors. The European Space Agency's Trace Gas Orbiter, launched in 2016, is designed to study Mars's atmosphere in detail. It measures methane concentrations and searches for other trace gases. So far, the results have been puzzling. Some measurements show methane, others do not. The methane may be localized, released in bursts, and quickly dispersed. Finding the source of Mars's methane could be one of the most important discoveries in planetary science. If it's biological, it would suggest life exists on Mars, even now. If it's geological, it would tell us Mars is more active than we thought. Either way, the answer will reshape our understanding of the red planet. Future human missions. NASA, SpaceX, and other organizations are planning human missions to Mars. These missions are still years, perhaps decades, away. But the vision is clear. Land astronauts on Mars, explore the surface, conduct experiments, and return safely to Earth. Or establish a permanent presence, a base, where humans can live and work. The challenges are enormous. Getting to Mars takes months, and astronauts would be exposed to radiation, isolation, and confinement. Landing on Mars is difficult because the atmosphere is too thin for parachutes alone, but thick enough to cause problems during descent. Once on the surface, astronauts would need life support, food, water, and shelter. And eventually, they would need to return, launching from Mars's surface and making the long journey home. But humans are explorers, dreamers, builders. We've always pushed boundaries, and Mars is the next frontier. Mars in popular culture. Mars has captured human imagination for centuries. It's been the setting for countless stories, books, films, and TV shows. H.G. Wells's The War of the Worlds imagined Martians invading Earth. Edgar Rice Burroughs's Barsoom series depicted Mars as a dying world, home to ancient civilizations. Ray Bradbury's The Martian Chronicles explored the poetic, melancholic colonization of Mars. In modern times, films like The Martian and Total Recall have brought Mars to life on screen. Mars represents both danger and possibility, the unknown and the familiar. It's close enough to seem reachable, but alien enough to spark wonder. In stories, Mars is often a mirror, reflecting our hopes, fears, and dreams about the future. The Mars helicopter, Ingenuity's legacy. Ingenuity, the small helicopter that flew with perseverance, changed how we think about exploring Mars. It proved that powered flight is possible in the thin Martian atmosphere. Future missions may include larger helicopters or drones to scout terrain, carry instruments, or transport samples. Ingenuity completed over 70 flights, far exceeding its original plan of 5. It explored areas Perseverance couldn't reach and tested new navigation systems. Ingenuity's success opens up new possibilities for faster, more flexible exploration. One day, the skies of Mars may be filled with flying robots, surveying the landscape, searching for signs of life. The symbolism of Mars. Mars has always been a symbol. In ancient times, it represented war, bloodshed, and conflict because of its red color. In modern times, it represents exploration, ambition, and the future of humanity. Mars is the next step, the next world, the next challenge. It's a place where we might start fresh, build new societies, and answer old questions. But it's also a reminder of fragility. Mars was once more like Earth, with water, perhaps life. But it changed, became cold, dry, inhospitable. Mars is a warning and a lesson. It shows us what can happen to a planet when conditions shift, when protection is lost. It reminds us to cherish Earth while reaching for the stars, drifting into sleep. And now, as we drift away from Mars, the red planet slowly fades into the distance. Its rusty surface, its towering volcanoes, its ancient river valleys, all recede into the darkness. You've traveled far tonight, across a world of extremes, from the tallest volcano to the deepest canyon, from frozen poles to dusty plains. You've learned about a planet that was once warm, wet, and possibly alive. And you've glimpsed the future, where humans may one day walk on Martian soil. Mars is waiting, patient, silent, turning slowly in the void. Its secrets are still hidden, beneath the dust, beneath the ice, waiting to be discovered. Tonight, as you rest, Mars continues its orbit. The sun rises and sets, blue light glowing at the horizon. Dust devils spin across the plains, clouds drift in the thin atmosphere, and ice sublimates from the poles. Mars breathes, in its own slow rhythm. And you, floating here in this quiet moment, are connected to it all. Made of the same elements, shaped by the same universe, part of the same cosmic story. The iron in your blood came from dying stars, just like the iron that colors Mars red. You are stardust, visiting another world, through imagination, through science, through wonder. Let your thoughts slow, your breathing deepen, your body relax completely. There's nothing left to do, nowhere left to go, just this moment, this breath, this quiet. Mars will still be there tomorrow, waiting in the sky, a red point of light, calling to us. Sleep well, and dream of distant worlds. Good night.